All right, here we go. Number 27 from our 0314 homework number 5 in MyLab Math. And the instructions say simplify by factoring. Assume that no radicands were formed by raising negative numbers to even powers. Okay, so we have a cube root of 135 x to the 8th. And what we're doing is we're looking for perfect cubes in order to simplify. Now, what I've done over here at the side is I've made this chart. I highly recommend when you're trying to simplify radicals that you keep a chart handy of maybe the first 7 perfect squares and cubes. And if your index is a 4, then you want to do to the 4th power also, okay? So just quickly to generate this to show you what I'm talking about, 1 squared is 1, 2 squared is 4, 3 squared is 9. So we're just generating perfect squares here. 16, 25, 6 squared, 36, 49. 7 is about as far as you need to go. And then for the perfect cubes, 1 to the 3rd is 1. 2 times 2 times 2 is 8. 2 cubed is 8. 3 cubed is 27. Again, I'm doing perfect cubes. 4 times 4 times 4, 64. 5 times 5 times 5, 125. 6 times 6 times 6, 216. I'm going to check that one. 6 to the 3rd, 216. And 7 times 7 times 7, 343. And so this is just a list of numbers that we're going to refer to in a second as we try to simplify this radical. Now, the first thing I do highly recommend that you do if you have a Casio ClassWiz is to try to cube root the number they give you. So we're going to try to take the cube root of 135. Obviously, it's not going to work because it was not in the list. And when I say it's not going to work, I mean it's not going to give us an integer. It's going to cube root, of course, but it's not going to be a nice whole number, okay? If it did, it would appear right over here in the list between 125 and 216, okay? So watch this. Equal, bam, not a nice whole number. So our job is to look for factors of 135 where one of those factors does occur in our list of perfect cubes. And so we're going to take the number 135 and we're just going to start dividing it by numbers that we know go into 135. For example, 135 ends in a 5. So I know that 135 will divide by 5 evenly. And it's 27. Oh, and notice this, 27 is one of my cubes. So what that tells me, it says I can rewrite the cube root of 135 as the cube root of 5 times 27, because 5 times 27 makes 135, okay? And now I've broken off a piece that I can cube root. Now, for x to the 8th, in order for that to simplify, the index has to be able to divide into the exponent evenly. And 3 does not go into 8 evenly. And so what we're going to do is we're going to break off powers of x until we get an exponent that 3 will divide into, okay? So let's say 1 and 7. 1 and 7 add to make 8, but 3 does not go into 1 or 7 evenly, and so we're going to have to try again. How about 2 and 6? If I multiply x squared times x to the 6th, if I add the powers, I get 8. Oh, and look at this. 3 goes into 6 evenly. And so now I've broken off a factor where I can pull some x's out, okay? Now then, we're going to have the cube root of the 27 is going to get to come out because it's a perfect cube, and the cube root of 27 is 3. So we get a 3 for a coefficient out front. And how many times Does 3 go into 6? Well, 6 divided by 3 is 2, and so that means that we're going to be able to bring out an x squared. Now, what's left underneath? Well, the 27 came out, and the x to the 6th came out, so we're left with a 5 and an x squared. So we have a 5 and an x squared left over, and that should be simplified completely, okay? Now, that is one technique that you can use to work the problem. I think what I'd like to do is demonstrate another technique, okay? Just for fun, we're going to look at another technique here. All right, so let's say again that we have the cube root of 135, and I would like to find the prime factorization of 135, okay? So if I type in 135 and hit equals on my calculator, there's this in yellow, it says fact. If I hit shift and fact, it's going to give me the prime factorization of 135. Do you see that? It says 3 to the third power times 5. So what does that mean? That means 3 times 3 times 3 times 5 makes 135. Okay? And we can check that real quick. 3 times 3 times 3 times 5 does indeed make 135. That is the prime factorization of 135. Remember, the index says if you've got 3 of a kind, you can bring 1 out. So writing the 135 as its prime factorization shows me that I do have 3 of a kind, and I can bring a 3 out, and the 5 is going to be left over. Okay, so that's one way that we can do the 3 and the 5. Now, for the x's, and I do not recommend that you do this every time. This is just another technique, okay? What does x to the 8th mean? Well, it means x times 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 x. It means that I've got 8 factors of x. I could rewrite x to the 8th as 8 factors of x. And again, what does the index say? It says if I've got 3 of a kind, I can bring 1 out. Okay, so those 3 can come out as an x. But look, I have another 3 of a kind. So that means that I can bring out a whole nother x. And those x's that are out front, those are going to get multiplied to make my x squared. Notice I've got 2 x's left over, which makes the x squared left underneath, okay? So again, this is just a different technique, a different strategy for looking at how to break those radicals down, how to simplify your radical expression completely. Now, let's see if I'm right. 3x to the second. We need to do a cube root, and that's going to be this guy, nth root. And I'm going to need to fill in the index with a 3 and the radicand with a 5x squared. Check it out. Man, I hope that was helpful. If you have any questions or comments, feel free to leave them in the comment section below, or you can text me. And thanks for watching.